Hello and welcome everybody. Today is the day 8 of our Smart 25 Days challenge, and today we are going to make a time logged bank smart contract, and it would be the extension of the previous smart contract, which was a time delay smart contract. So, today, what we are going to make is a smart contract which will act as a bank. And as I told you in the previous video, that we can apply the principle of time delay smart contract to simulate a bank kind of smart contract also. So, now in today's video, we are going to see how we can do that. So, basically, first of all, let us create our new file. That would be, let's call this bank.sol. So now let us first of all let us understand what we are going to create. So in this smart contract, users would be allowed to deposit some funds, and they would be asked for how much now a time they want to keep their funds inside this smart contract. And after that specific duration has passed, the users would be allowed to retrieve their funds. Uh, we can think of this as a fixed deposit, and there may be many practical uses of this smart contract in the real life. And to begin with, I will first give you the brief of what functions which we are going to create and how we are going to proceed in this smart contract. Uh, Basically, we want that each user should be able to deposit some funds, and each user may want to store more than one fund. So, if a user wants to store 2 ETH at for a specific duration, and then again he wants to store some 5 or 10 ETH for some specific duration, so he should be allowed to do that. So how we are going to do it is in a very simple manner. We are going to create two functions. One would be for depositing the funds, and one would be for withdrawing the funds. And for the deposits, we would be creating a struct. That struct would be keeping track of the deposits made by the user, and it would help us in to retrieve the funds and to deposit the funds. We are going to create along with that is that we are going to create a mapping, and in that mapping will help us to associate each user with its deposits. So what we are going to do is we'll create a mapping which will in which the key would be the user's address, and the values would be an array of the deposits made by the user. And how we are going to do it is as follows. So now let us proceed, and I'll may make sure that you get that I clear out everything and you don't have any doubts. So first of all, I have given you a brief introduction what we are going to do today, and now let us begin. Let us call our contract bank only. Now, the first of all, we'll create a struct, and how we create a struct I have told you before also. So this is the syntax of creating a struct, and now we are basically we are defining its properties. So now let us define its properties. Its properties are that it should contain amount, it should contain the release time, and then boolean whether the funds have been withdrawn or not. Now let us create the mapping which I was talking about. Address, an array of deposit struct. Let's call this mapping something. And first of all, its visibility is, let us keep it private only, and let us call this deposits. We have named this mapping as deposits, and now we are creating our first function. That would be to deposit the funds. So what it would take is, it would take the duration. Which duration? The duration for which the user wants to keep his funds or her funds logged. Duration, it should be public and it should be payable. So let us make sure that the user sends some value along with this, otherwise he should not be allowed to call this function. Amount should be greater than, should be greater than, greater than 0. Okay, looks fine. So, and let us, yes, okay. Now, let's also make one thing is that sure that this duration is the time which the user will give us in seconds, and the actual release time would be block dot timestamp plus this duration. Okay, release time should be block dot timestamp plus this duration. Okay, so yes, so now what we are going to do is, as soon as the user deposits some funds, we want that his address should be mapped with uh, his deposits. So what we are going to do here is, we are going to create a new deposit struct, like the instance of this struct here, and we want that to be pushed into this array, this deposits array, this array, and it should be mapped with the address of that user. So how we are going to do it is simple. So deposits message dot sender, then push, and then we'll create this deposit. So what we are doing here is creating the instance of this deposit struct and pushing that into this array of deposits, and mapping it with the value message.sender, that is the address, because so that it could be mapped with the address. And now let us proceed further. Deposit, and so this is the manner in which we assign the values to the properties. Amount should be message dot value, and then what we need, release time should be the release time which we have calculated just now, release time. And just one more thing, whether the person has withdrawn. So as has just now deposited, so we'll keep it as false. So because at the time when the person calls this deposit function, he is not yet withdrawn. He is not yet withdrawn any funds, so we are keeping it false. So that's it. And now let us Yes, close this. Simple. Look great. And so now we can proceed further. So now we are going to create the second function. Okay. So our second function would be to withdraw, and that function would be pretty straightforward. Withdraw you, that function would be asking for the index of the deposit which he or she, the user, wants to withdraw. So what will happen is, if a user has deposited five funds at five different times and he wants to withdraw anyone, so how he or she would be able to withdraw the funds would be by telling us the index of that fund which he she wants to withdraw. So I would be demonstrating how this works, so it would be more clear. So now let us just write down this function. Required condition should be that the deposit index should be less than the deposits. Actually, what it means is we are keeping a check to make sure that the deposit index provided by the user is less than the deposits made by him. So how we are going to do it is, we are checking that the array of deposit struct should the length of it should be greater than the deposit index provided by the user. Message dot length. So what happens here is, this deposits message dot sender dot length. This thing deposits message dot sender. This thing retrieves the array. This thing retrieves the array, because this deposits is the name of the mapping. This small d deposits is the name of this mapping, and then this thing deposits message dot sender. This thing retrieves the array associated with message dot sender. Message dot sender uh, is the address of the user calling this function. So what happens is, this mapping associates the address with the array of deposit struct, this deposit struct. Okay, so when we call this thing, this deposits message dot sender, what it retrieves is the array of these deposits. So basically here, this is actually the array of deposits made by the user, and then we are checking the length, whether the user has made that many deposits or not. So if he has made those that many deposits, then only he should be allowed to proceed further. Otherwise, the deposit index provided by him is wrong. So otherwise it should be invalid. Deposit index. It looks fine. So now when we have checked for it, what we are going to do is, let us create the instance of this deposit struct. So which deposit struct is the deposit struct associated with the user. Deposits message dot sender, and then deposit index. I hope it's clear. What we are doing here is, this deposit storage user deposit, this helps us that because why we have used this storage keyword is because we want to make changes to the state of this struct. the struct which we'll get here. So this deposits message dot sender is what? This is just the array. Okay, so you can assume that this is nothing but just the array, and the array which is associated with the specific user. Okay, so the array mapped with the address, okay, of the user which is calling this withdraw function. So this is the array, and as we retrieve something from our array, this is basically that only. So as you know that for if you want to retrieve something from the array, you just call it add of 0. So what happens is, say if you have an array by the name of a so a of 0 will provide you the value stored at value at 0th index. So this is what is happening here only. So this deposits message dot sender is helping us to retrieve the array associated with this message dot sender, and then this deposit index is giving us the specific value stored at that index. Okay, so which index which the user will give us, and this deposit storage user deposit is what it's doing is, this deposit is the data type. Okay, so data type is the user defined struct what we have defined here only, and this storage keyword means that we want to change the state of this value which we'll get from this line, and value we'll get the value stored at the index which the user has provided us. So if say the user provided us with the deposit index as 0, so we can say that value stored at index 0. Okay, so what happens here is, this deposit is the data type, and this storage keyword means that we want to change the state of this value, which value, which is stored at the index provided by the user, let us say that is 0, and we want to change that is the state, so that in the blockchain the changes would be made sure, and so that after the funds have been withdrawn, so we can flag this boolean variable as true, that yes, the user has withdrawn his or her funds. I hope I am very much clear, and if you guys have any uh, queries, then you can ask me out in the comment section. So now what we'll check is, we'll keep some required conditions, that would be that user should not have withdrawn the funds. And if you guys have any confusion why we are using the not operator here, yeah, then you can watch my previous videos. I have told before only, but just to make myself clear, I will repeat here in brief terms that what happens is, this require the basic principle of require condition is that the condition should be true, and then only the next steps would be followed. The steps below this would be followed, otherwise they would not be followed, and this error message would be displayed. So when we want that the user should not have withdrawn his or her funds, then we so for that we are keeping this not. Why? Because say the user has already withdrawn his funds, so the value which would be retrieved by user deposit dot withdrawn by create the benefit of creating this local instance, you can see, as you can see now, that the value which we retrieved from this is now stored in this user deposit, and to we are able to access its properties. So user deposit dot withdrawn will give us what say if the user has withdrawn his funds, so it will say that true, the user has withdrawn his funds. So if we'll not keep this not operator here, what will happen is this true value will mean that yes, the required condition is being fulfilled, and the next the for following steps, the below steps would be followed. But we do not want that. Why we don't want that? Because if the user has already withdrawn his funds, we do not want him to proceed and take the funds again. So that's why we are keeping this not operator. What in this, what will happen is if the user has already withdrawn his funds, it this value user deposit dot withdrawn would be true, and because of this not operator, it would be made false. And then when, say, let me just keep it here. So, say the user has already withdrawn his funds, then the user deposit dot withdrawn would be true. And what this not operator will do is not operator will make it false. So that's what we want, because we want that if the user has already withdrawn his funds, that yes, the user deposit dot withdrawn is true. So he should not be allowed to withdraw the funds again, and that should only be possible when this required condition, this is false. And so to make that condition false, what we are using is the not operator. So this not operator makes this true value, that yes, the user has withdrawn his funds, makes it false. And as soon as this becomes false, this value becomes false, the error message, this funds that the funds already withdrawn, get showed. And that's what we want. We want this only. So to fulfill our desired purpose, we are using this not operator here. I hope I am very clear. If you want any further explanation, then you can watch my previous videos and or can ask me in the comment section. So, oh, now another thing which we want to check is that the block dot timestamp should be greater or equal to what, the release time. So user deposit and we'll say that otherwise that the release time has not yet passed. That's it. Now let us if the following checks do follow. So what we'll do is we'll make the user deposit dot withdrawn to be true, and then pay the user his funds. Transfer user deposit amount. So I hope I am very much clear as we are done with this function. So as you can see that this user deposit helped us to access the values which would be stored at the deposit struct provided at the index which the user will provide us. So I know it may sound a little bit confusing, but I have tried to make it as simple as possible. Even if after that you have any questions, any queries, you can ask me. And just to repeat once more, I will once more try to explain this line. So what happens here is this deposit means the data type. Okay, this is the that the user defined deposit struct. Okay, this storage keyword means that yes, we want to make the changes to the state of the value which we'll retrieve from this, and this value which we'll retrieve from this is getting stored into the user deposit variable. This user deposit this user deposit name variable stores the value which we retrieve from here. And what is the benefit of using this user deposit here is that now we can easily access the properties of that struct which we retrieved from here. Okay, and the properties of the struct are three properties: the amount, the release time, the boolean flag withdrawn. Okay, so and how this works is simple. Deposits is the name of the mapping. This deposits is the name of the mapping. And what we are doing is we are accessing, we are basically retrieving the array by using deposits message.sender, because in the mapping we have in the mapping which we had created, we had associated the addresses with the array of deposits. This capital D, please keep the check or don't get confused, keep the check between the small d and capital D deposits. Okay, and this is single deposit. So what we are doing here is by using this deposits message.sender, we are able to retrieve the array associated with message.sender, this address. So this deposits message.sender will help us to retrieve the array, and after retrieving that array we are accessing the element of that array. And which element we are accessing? We are accessing the deposit index, the index which the user provided us. So as I told you, this deposits message.sender can be thought of as an array which could be named as ARR, and then this deposit index is the index which the user has provided us. Say he has provided 0 or say 1. So by this we are accessing the value stored at this index which the user provided us. I hope I am very much clear. So that's all for this. And if you want, yes, we can create some more functions such as to see that how many deposits are there for a particular user. So we can create a function maybe called get deposit count, and for each specific deposit we can also make a function to get the value of that deposit. So let us create them too. Function get deposit count, as it's only a view function. Return deposits. So the length of the array, which array associated with the message.sender. So this is what is happening here only, and which I explained just now. This deposits message.sender will help us to retrieve the array, and as soon as we get the array, we can use the functions of the array such as length, and this will help us to know the number of deposits. Now to know about each deposit, get deposit. So it will take the parameter as deposit count, index, sorry, deposit index. What it will return? It will return all these three things: amount, release time, and withdrawn, whether the person has withdrawn or not. So, so the get deposit will also check that whether the index provided is correct or not. So you can use this same condition here. And then if it's true that yes, the deposit index is actually less than the length of the deposits array of deposits, so then we'll create we'll basically do the same thing here also. Deposit. Deposits. So now for amount, the amount would be, to return the values, the amount would be user deposit dot amount, release time would be user deposit dot release time, and the withdrawn would be withdrawn. That's it, and let us now try to deploy it, compile and deploy it. So it has successfully compiled. Let us try to deploy it. Okay, so now say this user wants to deposit some funds in ETH. He wants to deposit, say, 2 ETH, and then for the duration of 20 seconds, he will click on deposit, and yes, he has successfully deposited his funds. So to get the deposit details, we'll just click that yes, because this is his first deposit, so this would be stored at 0th index. You can get here that the for a specific user, this get deposit count with will return the number of deposits made by him. So as the user currently have only one deposit, so at 0th index it would be stored. And if he tries to get retrieve the value of first index, it would be shown as invalid deposit index. So now this user wants to store some more ETH into this smart contract. Say now he wants to store 5 ETH, or say 5 seconds deposit. So now the balance of the smart contract becomes 7 ETH, and now for this user you can see that deposit count becomes 2. And for first index you can check, okay, this is the release time, this is the actual release time, which is combined with the block dot timestamp, after which the user would be able to retrieve his funds. Say there is some other user. Let us try to check whether he has some funds or not deposited. So the get deposit funds is zero for him, for some other user. Now if so, let us check for some other user, and say this user wants to store some funds, say 10 ETH, and for the duration of 20 seconds. So his funds get deposit here, and let us know the funds count. Okay, so he has deposited 3 funds. Let us try to retrieve it. So before the release time, the error would be shown that release time has not yet passed. So it is working correctly. And now let us try again. So now it works fine because the release time must have passed. So if the user again try to retrieve those funds, let us see what happens. Some error is shown, that is funds already withdrawn. So this makes sure that the funds, once the user has retrieved them, he or she should not be able to retrieve them again. So that's all for today, guys. I hope you liked it. And if you guys have any queries, then please ask me out in the comment section. Thank you. Bye bye.